So in this lesson, we're going to be using trigonometric identities, but now we're just going to be verifying. So you can use the fundamental identities from this chapter to verify new trigonometric identities. When verifying an identity, you're going to begin with the expression on one side. Use algebra and trigonometric properties, and we're going to manipulate the expression until it is identical to the other side. So when we are verifying, we are not solving. What's happening is that one side is really the answer. One side is the answer. And so, for example, like this one, this is the answer we want to get to. Then we have this other side, the sine squared of theta minus 1 over secant squared of theta. That is what we're trying to manipulate. So really, just think about verifying as we have the answer here already for us. We want to try to make this the same. Okay, so let's try this out. And the general rule is that you want to manipulate the side, or begin with the side with more terms. Begin with the side with more terms. Okay, so you can definitely see on this side we want to do the left-hand side. We want it to equal the right-hand side. So secant squared of theta minus 1. So that looks like one of our Pythagorean identities, secant squared of theta. So that reminds me of 1 plus tangent squared of theta equals secant squared of theta. And so if we subtract 1 from both sides, then we have tangent squared of theta equals secant squared of theta minus 1. So because secant squared of theta equals 1, here we can replace tan squared of theta at the top. So let's do that. So we'll write tan squared of theta, and that's going to be over the secant squared of theta that we had originally. Okay, and so we're trying to get it to look like sine squared of theta. So now let's manipulate tan squared of theta. Tan squared of theta is sine squared of theta over cosine squared of theta. Then we have the secant squared of theta. Secant squared is 1 over cosine squared of theta. So now that we have this, we have a complex fraction, so sine squared of theta over cosine squared of theta. And then we're going to divide by 1 over cosine squared of theta, or multiply by the reciprocal. So when we do that, we get sine squared of theta, and now this looks exactly like our right-hand side. So this is correct. So that's one way to do it. So I just want to show you that there are other ways to do it. So what if we did this a different way? Okay, so let's do this a different way. I am going to, instead of saying secant squared of theta minus 1 equals tan squared of theta, we could have said this as well. We could separate the fraction secant squared of theta over secant squared of theta minus 1 over secant squared of theta. So I just split it up, right? So I have this, and then I have that one. So secant squared of theta over secant squared of theta, that's 1 minus 1 over secant squared of theta. And then secant squared of theta is 1 over cosine squared of theta. And so you can kind of see that, right? So you multiply by the reciprocal. So this becomes 1 minus cosine squared of theta. Then remember the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. So in order to make this look like that, we can subtract cosine squared of theta from both sides. Squared of theta. And so now sine squared of theta equals 1 minus cosine squared of theta. So here we go, sine squared of theta, and it's the exact same as the right-hand side. So again, there's different ways that you could solve for it. So notice that verifying an identity is not the same as solving an equation. When verifying an identity, you cannot assume that the two sides of the equation are equal, because you are trying to verify. So let's see, assume that two sides of the equation are equal because you are trying to verify that they are equal. So we have the answer we want it to equal. We want it to be the same. So you cannot use properties of equality, such as adding and subtracting the same quantity to each side, right? So I can't subtract 10 of x and subtract 10 of x, right? We're not solving. All right, so let's try this example here. So I'm going to go ahead and do this left side, secant of x plus tan of x, and I want to make it look like cosine of x over 1 minus sine of x. So secant of x, that is 1 over cosine of x, and tangent is sine of x over cosine of x. So this is nice because we have a common denominator, so let's rewrite this. 1 plus sine of x over cosine of x, so just a common denominator. And now, looking at this, I'm looking at my right-hand side. On the right-hand side, I notice I have a 1 minus sine of x. I don't have that on my left-hand side, this side that I'm working with. So what I'm going to do in this case is I'm actually going to multiply by 1 minus sine of x over 1 minus sine of x. So this at the bottom is just telling me that I want that. So in order to get that, I'm going to multiply that to this side. Okay, so I'm not using the left side, I'm just using it to help me with what I need to do on the left-hand side. So when I do that, notice I have this top portion is our a plus b times a minus b, so it's that special pattern of a squared minus b squared. So the top portion becomes 1 minus sine squared of x. Sine squared of x. Then we have cosine of x times 1 minus sine of x. And then remember now that the 1 minus sine squared of x, that is just cosine squared of x over cosine of x times 1 minus sine of x. So because this is squared, cosine squared of x, there's two of them and I have one at the bottom, I can just cancel one of the cosines out at the top. So take out the square and this is gone. And so now for my final answer, I have cosine of x over 1 minus sine of x. So now I have gotten my left-hand side to equal the right-hand side, and so this is done. If you try to do the right-hand side, if you tend to get stuck, like if you try it out and you're like, oh my gosh, I don't know what's there, you can always try the left-hand side and see if you can get it to work as well. So go ahead and try the next 6 examples on this side and this side. Then on the next video, I will have the answers that you can watch.